Hello everyone, and welcome to SCOMathon 2023. My name is Stoyan, and I'm delighted to be speaking to you today. I'm a senior principal consultant and partner at Pwn IT Consulting, a Swiss-based consulting company. I'm six-time Microsoft Cloud and Data Center MVP, mainly because of my PowerShell and SCOM-based contributions. In this presentation, we'll be discussing how to use PowerShell with SCOM to solve custom monitoring challenges without having any management pack authoring knowledge whatsoever. We'll start by taking a look at the agenda and then dive into the details into the coming slides. Before we jump to what this session is all about, let us shortly look at the agenda. We will discuss the benefits of using PowerShell with SCOM. We'll review traditional management pack authoring versus management packs authored with PowerShell. We'll look at Cookdown's PowerShell management pack, a discrete solution. And of course, we'll cover some PowerShell and SCOM use cases like monitors, rules, recovery tasks, and command channels. And at the end, we'll take a look at some of the best practices, some do's, some don'ts. Before we discuss how PowerShell is used with SCOM, let's clarify why we use PowerShell in the first place. Compared to other scripting languages, PowerShell offers several advantages for SCOM administrators. For one, it has a simpler syntax that is easier to learn and use. Additionally, PowerShell has an access to the full range of .NET libraries, providing flexibility and also, of course, extensibility for custom tasks. This means that almost anything within the Windows ecosystem can be scripted or automated using PowerShell. There are two primary areas within SCOM where administrator can utilize PowerShell. The first would be managing and automating SCOM as an application and also some infrastructure-related tasks. For the purpose, we can use one of the countless CMDlets for SCOM, which can be found online on the Microsoft Learn site. The second area, which is actually the main focus of the presentation, involves authoring various monitoring workflows using PowerShell. These workflows mainly include rules, monitors, and recovery tasks. Now, many of us have faced the challenge of implementing custom monitoring logic for a customer. While this task may not be complex, it often requires tailored logic in order to meet the customer's specific requirements. Now, what would you do? The first step is usually to search for a vendor or a community-based management pack to cover the specific needs. And in many cases, the available management packs are unable to do so or unable to cover your requirements or address the challenge at hand. This is where PowerShell comes to the rescue. With a basic knowledge of PowerShell, any challenge can be quickly addressed and turned into a solution. Let's see how in the coming slides. Management pack developers typically use Visual Studio together with the Visual Studio authoring extensions to develop a management pack for SCOM. These tools provide really a great suite of features and functionalities for building and developing high-quality management packs. However, there are also other products available, such as Select MP Author or MP Studio, which offer wizard-driven engines that guide users through the creation of all important elements, including rules, monitors, performance rule, and more. These tools make it easy to build really sophisticated and almost commercial-grade management packs without requiring extensive programming skill or expertise. Regardless of which authoring solution you choose, you can also leverage the management pack fragments created by Kevin Holman in order to speed up and simplify the authoring process. These fragments provide pre-built code snippets that can be easily customized and integrated in your own management pack, saving you time and efforts. Overall, there are a variety of tools, of authoring tools and resources available to management pack developers, each with its own strengths and benefits. Despite the availability of variety of authoring tools and resources, why doesn't everyone just develop management packs to cover their needs? And the answer to this is because in the most cases, it's not that easy to do so. Authoring can be a time-consuming and complex process requiring a certain level of expertise and, of course, knowledge. And let's admit it, in the most cases, deadlines are inevitable and our solution needs to be ready by yesterday. Even with the help of wizard-based tools like MP Author Pro or MP Studio, you still need an extensive knowledge of classes, inheritance, key properties, and all the other terms that are associated with advanced management pack authoring. Of course, you need to invest time in testing, in bug fixing, which is an integrated part of the development process. This may involve writing and running test scripts, performing manual testing, and using debugging tools to solve your issues. If you're unable to author the management pack yourself, it may be necessary to hire a skilled expert with the necessary expertise to address your requirement. You need to find an expert with experience in SCOM and, of course, management pack development, who is able to provide you with the necessary support in order to successfully implement a management pack. And this, of course, is an additional investment. Lastly, it's important to know that learning and mastering the process of management pack development for SCOM may not be an easy task. It requires a significant amount of time, effort, and of course, dedication to gain the necessary skills and expertise. So we have a certain challenge here, how to meet certain custom monitoring requirements and at the same time avoid doing management pack authoring and all the complexity associated with it. Here is where PowerShell comes to the rescue. PowerShell can simplify the management pack authoring process by reducing the complexity and the time required to author a management pack. With PowerShell, SCOM administrators can automate the creation of management packs and easily modify them to suit their needs, which can significantly save time and, of course, effort compared to the manual or to author a management pack with Visual Studio and the authoring extensions. When comparing the use of PowerShell for authoring with Visual Studio and the authoring extensions, it's important to consider the key differences between two. While Visual Studio provides a more comprehensive development environment for creating complex management packs, PowerShell, on its hand, offers a simpler and more efficient approach for creating and modifying those. PowerShell offers several advantages over Visual Studio authoring extensions for management pack authoring. One of the key benefits is efficiency, as PowerShell allows for a more streamlined and rapid development process. Additionally, PowerShell provides greater flexibility in terms of modifying existing management packs or creating even new ones. And of course, the simplified syntax also makes it easier to learn and use, and you can easily find pre-existing PowerShell scripts online to help you with your monitoring needs. However, using PowerShell for management packs, for management pack authoring may have some limitations, such as lack of advanced development features, and of course, the need for some technical knowledge and expertise in PowerShell itself. Meanwhile, Visual Studio, together with the authoring extensions, provide a more comprehensive development environment and approach, but may require more time to learn and use efficiently. And now to the big question, how can I cover my monitoring needs or the needs of my organization with SCOM and PowerShell. There is one solution out there that allows us to create different monitoring workflows using any PowerShell script that we get our hands on. It's called the PowerShell Authoring Management Pack, and it's available for download on the Cookdown's website. The PowerShell Monitoring Management Pack extends Microsoft System Center Operations Manager and allows the creation of PowerShell-based monitors, rules, tasks, diagnostics, and also recoveries directly from the SCOM console using the authoring tab. The cool thing about this is no management pack authoring knowledge is required to create those. Authors can leverage their existing scripts, and the UI also contains the samples they need to modify in order to get those working with SCOM. One more cool thing about the solution is the fact that it is absolutely free. Before you dismiss my recommendations as mere promotion, let me clarify that as a consultant, I have utilized this management pack more frequently than any other management pack from the standard, apart from the standard ones such as Windows Server Operating System, Windows Cluster, SQL Server, Exchange, IIS, etc., etc. In most cases, customers and end users want a solution that solves their problems quickly, efficiently, and of course at a reasonable cost. When faced with such scenarios, I find myself turning to PowerShell rather than to Visual Studio. And PowerShell's simplified syntax and the ability to find scripts online through a simple search make it an efficient tool for addressing custom monitoring needs. Just a few more words on this management pack. To make use of this management pack, you need to, of course, SCOM installed and configured in your environment. From that point, all you need is enough knowledge of PowerShell scripting, to accomplish whatever monitoring tasks are required. The management pack adds support for PowerShell everywhere that you'd expect it to be in the SCOM console, in the authoring pane. So it feels like a native extension to the SCOM UI. There are wizards which are added to the authoring pane in the SCOM console. They use the same steps as the built-in wizards, but with PowerShell support instead of VB script. The management pack is completely free, as we already mentioned, and also open source, and it is available also on GitHub. If you want to get to know it a bit better, you can watch the complete walkthrough either on the management pack homepage or also on YouTube. The link is included on the slide. It is important to understand exactly what we can utilize this solution for. So below are the monitoring workflows we can use the management pack for. So PowerShell based monitors. Those, as we all know, can be used to monitor custom metrics, event logs, performance counters for a wide range of infrastructure components, including servers, applications, and also databases. Of course, PowerShell-based rules used to detect specific events or conditions such as service failing or disk running out of space, and then execute corrective actions such as restarting a service, triggering an alert. PowerShell-based recovery tasks. You can automate corrective actions such as restarting a service or running a script to restore the health of the infrastructure after an issue has been detected. Of course, PowerShell-based command channel, you can use it for triggered alert updates or to create custom workflows and automations which are executed on a certain condition which can be defined within a SCOM subscription. So let's see what the specifics are when creating a PowerShell-based monitor. To create The Create Unit Monitor wizard offers the option to create 2- and 3-state PowerShell-based monitors. It also provides you with the template, which is actually a sample script that already has the necessary boilerplate to work with the SCOM API, so no prior knowledge is necessary. The sample script also contains the property bags, which you will have to use at the next step of the authoring process, and in particular while defining the healthy and unhealthy conditions. The term property bag is important when creating PowerShell-based monitors, so let me shortly clarify it. In order to gather data using a PowerShell script and pass it back to the workflow to be used in different ways, the script returns data in the form of name-value pairs. These data and those name-value pairs are stored in this property bag. There is a great article by Tyson Poe on this topic only, and I would encourage you to go over it before creating your first PowerShell-based monitor. The template also allows you to specify a script and dynamically insert an argument based on the workflow target. Script will not be checked for correctness by the template, however, so you need to ensure you have thoroughly tested them prior to using those for your authoring process. Now, let's take a quick look at the options we have when creating a PowerShell-based rule. First, we have the possibility to create a PowerShell-based alert generating rule. The authoring process is similar to that of a PowerShell-based monitor, as seen in the previous slide. However, since it is a rule, there are no states involved, and the rule generates an alert based on a single criteria. Next, we have the event collection rule, which is a standard collection rule that allows you to collect events, with the added advantage of using PowerShell scripts to include additional information in form of a text or a description. This allows for more comprehensive event collection and, of course, analysis. We have also the performance collection rule template, which allows you to collect any performance metric from the targeted system in case you decide to do it the PowerShell way. Moving on, another useful and actually my favorite rule template is the run a PowerShell script rule, which allows you to execute any PowerShell script on a schedule. This is especially helpful for administrators who typically rely on scheduled tasks for this purpose. With this rule template, the configuration process is simpler and more intuitive than creating a scheduled task, and all the scheduled scripts are conveniently located with the application or with SCOM itself. This template can be used for repetitive cleanup tasks, health checks, automation tasks. For instance, you can use it to close alt alerts from rules once they reach a certain age, something we will see later in the demo. Finally, we have the run a PowerShell script on an event rule, which enables you to execute your PowerShell script immediately after a specific event is generated. This is extremely useful for taking corrective and recovery actions, or for starting an automation process as soon as a particular event occurs. Creating recovery tasks and command channels. Rules and monitors are common use cases for PowerShell-based authoring in SCOM, but recovery tasks and SCOM command channels can also benefit from the usage of PowerShell. We all, at some point, had to set up SCOM recovery or diagnostic task. As you know, out of the box, SCOM offers the possibility to run a command or run a script. Within the recovery task, I personally have used the run a command option in the past very frequently, and mainly by leveraging different basic commands for service restart, process queue, or other basic tasks. But to be honest with you, I faced the challenge every time. The requirements are to use a VBS script. And the thing is that despite my 15 years of experience in IT, I have never learned to properly use VBS. So as a result, I was unable in most cases to write scripts and to cover more complicated use cases. So imagine the relief I felt when I discovered that the PowerShell management pack also includes the option to run a PowerShell script as part of the recovery task. This offers me flexibility and to some extent also extensibility. By leveraging PowerShell as a script language, it is now effortless to create even complex recovery and diagnostic tasks. What about command channel? Moving on to command channels, I have a confession to make. I have never used a SCOM command channel with anything other than PowerShell. Whenever I have the option, I always prefer to use PowerShell. In my experience, the most common use cases for command channel is updating some kind of alert parameter, typically the custom field of an alert with a certain value. However, with the right imagination and skills, you can do anything. You only need some PowerShell knowledge and, of course, a PowerShell-based use case for that. And talking about use cases, let us shortly also mention what the actual difference between a PowerShell-based command channel and a simple execute a PowerShell script rule is. Compared to a simple rule where you can run a PowerShell script, a PowerShell-based command channel can execute a script when a specific alert is triggered, and it typically does not allow for dynamic input updates if this were a PowerShell script executed within a rule. So when you're using a command channel, you can specify inputs and outputs that can be passed back and forth between SCOM and your script. This makes it possible to develop more complex workflows that involve multiple steps, such as querying external systems, retrieving data, and updating alerts and objects in SCOM. Another benefit of using a command channel is that it provides more detailed logging and, of course, options for error handling. This allows you to troubleshoot any issues that might arise during the executions of your script more effectively. Overall, PowerShell-based command channels are a powerful tool that can help you automate tasks and, of course, improve the efficiency of your SCOM environment. Before diving into specific use cases and conducting a brief demo, let us look at some of the specifics associated with the PowerShell management pack and the PowerShell-based workflow authoring in general. Each template comes with a script that includes the necessary framework to work with the SCOM API. This means that even if you do not have prior knowledge of the SCOM API, you can easily customize the script by adding the API-specific parts, such as creating and filling property bags, etc., etc. In just a few simple steps, you can quickly create customized scripts and leverage the power of the API. It's important to know that PowerShell management pack for SCOM does not provide syntax checking for your scripts. Therefore, it's advisable to test your scripts thoroughly before using them or before using the templates in order to ensure they work as expected. By testing your scripts, you can identify any errors or issues and fix them before implementing them in your SCOM environment. This can help you avoid potential problems and, of course, ensure that your knowledge, that your workflow runs smoothly and efficiently. When passing arguments to the script in the PowerShell management pack for SCOM, it's important to know that they are passed as a single string. Therefore, if you need to pass multiple arguments to the script, you can use the string split method, with the appropriate separator in order to convert your arguments into an array. This allows you to easily handle multiple arguments in your scripts and perform the necessary operations. A word about PowerShell versions. The PowerShell Management Pack does not define or control which versions of PowerShell will execute any given script. This is determined by the runtime, at runtime by SCOM for each agent. This means that if all your servers have PowerShell version 3, for example, installed, you can write scripts with that minimum version in mind. Otherwise, you need to target the lowest version in your environment. It's always a good idea to test any script you may write against that version to ensure the widest compatibility prior to adding them to SCOM. The workflows generated by the management pack utilize a SCOM capability called cookdown. The feature allows scripts or any data source that are executed repeatedly to be executed only once and then share the output data. However, for cookdown to work, all instances of the script must be identical and have precisely the same input values, including schedule and overrides. If you want to learn more about this, just watch the walkthrough video on the website of Cookdown. There is really a detailed and excellent explanation there. Lastly, a few words on troubleshooting the whole process. After you have written your script, as already mentioned, it is a good idea to test it. In order to do so, you can simply return the property bag values to the PowerShell console. Tyson Paul offers some excellent examples in the blog article which we saw in one of the previous slides. The lesson I learned in the particular case is that you should not do that in the PowerShell ECE console, but should be using the normal PowerShell console when returning your property bag values. Besides this, you can always look in the Operations Manager event log to see if something is failing once you have created your rule or monitor. Of course, if you have question or need further assistance, you can also write in the PowerShell in the Squared Up forum, which is called Community Answers. I personally know a couple of top experts which will provide you with an answer there. And before demonstrating some of the cool functionalities we discussed earlier, let me share with you a couple of real-world use cases I personally encountered in the past few months. Although I couldn't find any pre-built management packs to address them, I managed to solve those using PowerShell, exactly the way I just explained, in a quick and I would say also an elegant manner. So the first use case we are going to review is monitoring a certificate revocation list which are placed on a network share. You know that typically CRLs can be discovered automatically, but if you have some custom, let's say custom infrastructure, and in my case, the CRLs were placed on a network share hosted by a Linux system, so the usual discovery over the Windows agent was not an option. So I did a PowerShell script, which gets all the files, which reads out the expiration date, and of course alerts in SCOM in case a CRL is about to expire. Another use case, user session monitoring. In order to see whether a certain user is logged in or not. Unfortunately, I couldn't find a management pack for this, so I prepared a very basic PowerShell script which does this for me and alerts in case a certain user is not logged on the system or is logged on the system. Another use case which also we are going to demo right now is the availability of network shares. So a customer of mine gave me the task to check if certain network shares are available. How can you do this? I found it very easy to to do this with PowerShell, so I did it. Another use case will be user password exploration monitoring. It is something I blogged about. I also included the script I'm using. So the task is to watch for Active Directory users and actually alert whenever passwords are going to expire. So this is a use case I also covered with the PowerShell management pack. Another use case I had a couple of months ago was file or folder timestamp monitoring, easy peasy with a simple script, very robust, worked like a charm. And actually, everything that you can think of, you can cover with PowerShell. Everything where you lack a management pack, a real management pack, when you don't find one, when you cannot author one, just take PowerShell, take the PowerShell management pack and do the magic. So now it is the time where we are going to do a short demo. The first thing I would like to show you is the use case we discussed previously, the availability of network shares. For this purpose, on my demo system, I have prepared two test shares, test share 1 and test share 2, which are currently shared. This we can easily check with the share command. And as you see, we have here both network shares which are available. So let us create a PowerShell-based monitor, which will just look for the availability of those shares. I have prepared very simple script here, which actually I'm going to go over it and explain you very briefly what actually the PowerShell script does. So here we are creating, or those are the rows which are talking to the SCOM API, and of course initializing the property bags. The script is very basic, so we just put the shares in an array, and we define also 2 additional arrays for available and not available shares. We do a simple check for the shares, whether they are available using the test path cmdlet. And at the end, depending on whether the share is available or the count of the available shares, we are filling those property bags. As you might see on the script here, we have the option to use multiple values to with the property bags. So for example, I have here the so-called name value pairs, not available shares, everything which is within this variable, then the state not available, and also I have the available shares. And at the end, the last thing we have here is just returning those property bags to SCOM in order for them to be evaluated. As you might see here, I have added another row which can be used to test the property bags. We are going to see this now, in case you would like to test your script prior to entering it in SCOM. Okay, so let's now create a PowerShell-based monitor which monitors our 2 shares. For the purpose, I'm just going to copy this script. And I'm going to navigate to the authoring pane, and here I'm going to create a new PowerShell, a new PowerShell-based monitor. So I'll create a unit monitor, and as you see here, I'm going to take the scripting PowerShell-based 2-state monitor. I'm going to place the monitor in a demo SCOMathon management pack, which I prepared earlier, and we'll give it a meaningful name like demo network share availability monitor. We will target the let's say Windows Server 2016 and above operating system class. Let's find it quickly. This is the one. And initially we'll create the monitor as disabled, and afterwards we are going to create an override which enables the monitor for a particular system. So let's see the creation process. Just go with next. Then you can here decide how often your script should be run. In my case, I'll just leave it every 15 minutes. And the next step is to define the name of your script. And my advice to you and my recommendation here would be to use a really meaningful name, because if you go to the task manager or take a process explorer as a tool on the agent which is running your script, you can easily identify what is actually running using the name of the script. So I will type here, for example, net share SCOM monitor. This way I'll know if I see the script in the task manager or under a certain process that this is script from SCOM, which is checking the availability of some shares. I'll leave the default timeout value to 1 minute, and then I'm going to copy my script. It's really a simple one, as we saw. I don't need this last row because we are going to use it for testing. And now I'm just going to click next. And here we have both conditions, the unhealthy and also the healthy expressions. This is where we actually enter our property back values for them to be evaluated. As we saw previously, in our case, the unhealthy conditions is the state which is not available. So here I have the parameter name which is already state, and I'm just going to copy this value, and this way SCOM will know, okay, this is the unhealthy condition where shares are not available. The next step would be to define the same, but for the healthy condition. In this case, the property value state has the value available. So I'm going to copy this here and then just click next. I'm going to decide here whether I want a critical alert or a warning or what actually the monitor state will be when the condition is detected. I will leave it as a warning here. And I'm going to want to generate an alert for this monitor. Now, what is cool here is that within an alert, we can also include additional values from the property bags. Like, for example, we see the available shares and also the not available shares, which I would like to list once a certain share gets unavailable. I'm not going to be entering them now because I'm just, in order to save some time, I'm just going to switch to my pre-created monitor for this, where we can easily see this, and I'm going just to click the create. The important thing is, of course, because we created the monitor by default disabled, please don't forget to create an override for your monitor. And now I'm going to reach out to an already pre-created monitor, just because it is very quick to do so. And in our case, we have this Scomaton 2023 network share monitor. What I would like to show you here is the additional property bags which I have entered in the alert description. And those are the available shares and the not available shares, which I got directly from those script variables. You see them here. And now let's put it to test. So I have this monitor. Let's first see if it's initialized and how it looks like. If I'm not mistaken, I have this targeted as SRV1 here. So I'm going to open the Health Explorer here. Let me show this more detailed here. And when I extend the availability section here under operating system availability, you'll see my demo Scomaton 2023 network share monitor. And you see also the healthy and unhealthy conditions, and also current state is available. This is what the script returns to SCOM here, as you see. And of course, the next thing we would like to check is also, excuse me, here is actually the available shares. So currently you see test share 1 and test share 2. And if I just go ahead and stop the sharing of, for example, test share 2, I'll just stop the sharing here, apply this, and then if I'm not mistaken, our monitor does the check every 2 minutes. So let's check it out. So our schedule is every 2 minutes. So in maximum 2 minutes, we should get an alert for the share not being available. So this again is a perfect example of a very simple task which can be automated with SCOM, something you don't have a management pack for, and something which is easily and quickly done using PowerShell. So until we wait for this monitor to turn again red, let us just show one last thing in SCOM, and this is how you can use a script in order to close old alerts from rules. So for the purpose, I'm going to do the following. I'm just going to the authoring tab and create a new rule. And within this rule, I'm just going to say I want a rule that runs a PowerShell script. I'm going to put it in the same management pack. I'm going to do next, and this will be demo close old alerts from rules. I'm again going to target this at the Windows Server 2016 and above operating system class. So let's find it here, and then just go ahead and just enter it to be run, let's say every 2 hours for me, because it will be cleaning up my environment, so I don't have to run it that frequently. And here I just put my script, and we'll see how simple this script is. Close old rule alerts is the name of my script, and I'm just going to grab the script here and just copy it. The script, what the script does is actually you can set here the age of the rules that have to be cleaned, and just get all the alerts which are actually not modified in the past 96 hours, like stated here, and then also resolve the alerts. I'm just going to copy this and put it within the script. And here is my script. So what the script does is it's going to start every 2 hours this rule, this script, and the script will get all the old rules which are older than the 96 hours, and then just close them. And before jumping back to our last slides, let us check our alerts, or the alert of the monitor which we had previously. Like you see here, the demo Scomaton 2023 network share monitor just alerted, and it's telling me that available shares are actually, or is actually test share 1, and not available shares is test share 2. In the minute I go ahead here and again share my network share, or this folder actually, this alert will disappear. So quickly back to our, let's say, last slide for the day, common pitfalls to avoid. There are some specifics we need to watch out for, and let's take a look at them. Proper error handling should always be a priority, especially in the realm of PowerShell, where it involves validating values or different variations of addressing other aspects. The same best practices and approaches could be consistently applied when using PowerShell scripts in the context of SCOM. Here are also some tips to optimize the performance of your PowerShell scripts within SCOM. So first, use the cooldown feature in order to reduce the number of times a script is run. Validate your input values to ensure they meet the expected criteria before processing them in the script. Try to use try and catch blocks. This will allow the script to continue running even if it encountered an error. Use logging in order to keep track of script execution and potential errors. This can help you identify issues early on and provide you a record of what occurred. Test it thoroughly before using it in production. This will help you identify any potential issues and ensure the script is working as expected. And of course, optimize the script performance by reducing the number of commands and avoiding unnecessary loops or queries. And of course, monitor performance to ensure the script is not causing any performance issues within SCOM itself. And with this, we have reached our last slide. Thank you for joining me today for this presentation on PowerShell and SCOM. I hope the information shared was useful and informative. Now I would like to open the floor to any questions you might have. Please feel free to ask me anything related to the topic, and I will do my best to answer your questions. Thank you once again for your time and attention.